Okay, so we're on. We'll see what shows up. Doesn't seem to have anyone on. Doesn't seem to be anyone on at the moment, so just hold fire just a sec. I'll just pop a message up. Okay, so this one's going to be about exercise 7D, which is the final exercise of statistics for first year, and that's two-tailed hypothesis testing. So let me give you some user page numbers so you can get yourself set up for this. The page number is 107 from the first year textbook. So that's applied one, right? So I'll give you a minute or two just to get yourself set up, and then we'll talk ourselves through two-tailed test. All right? And that's pretty much it. And that's the exercise you're doing. You might notice that we skipped 7C. The reason why is that there's going to be a video on 7C done at 3 o'clock. I mean, it's just a piece of plastic. Yeah, so just to reiterate, you think, well, we've done 7B. We're doing now 7D. When's 7C happening? It's because I'm going to do 7C with my normal maths class as well. So therefore, it's no point making 2 videos on the same thing. So at 3 o'clock today, there will be 7C covered as a video as well. So you'll go get 7B, you get 7C, and you get 7D. And after that, hypothesis testing is done. All right? So it's page 107 in the applied first year book, and it's exercise 7D we're doing. Just to reiterate, there will be a 7C as well. There will be a 7C video. It'll be on later on today, 3 o'clock. Okay, let's begin. So one-tailed test is done for a change in a direction. So a probability's either gone up or probability's gone down. Yeah, we're not sure whether it's gone up. We're not sure whether it's gone down, but we know which direction we think it might have gone in. A two-tailed test is just whether we think the probability has changed in either direction. So a H1 for a one-tailed test would be something like this. Probability is greater, probability is less than. A H1 for a two-tailed test would look like this. So it's implying there's a change, but we don't know what the change is. So an example of something that you might see a two-tailed test is if we do something one way for some years and then we change up what we do, we might not be sure whether it's going to be better or worse. That's what we call for a two-tailed test. And the fundamental difference between a two-tailed and a one-tailed test is a two-tailed test, you split your confidence interval into 2 equal parts. And we've seen some of this already when we did the critical regions and critical values. So you're hopefully quite familiar with the idea already. And what we're going to do is we're going to look at, first of all, we're going to look at example 6. So example 6 can be found on page 107 of the textbook. So page 107, and we're going to look at example 6. I'm going to give you a minute or two just to kind of pull that up on whatever screen you've got, and I'm going to go through that, okay? So just to be clear, we're doing exercise 7D, page 107 from the applied 1 textbook, and we're doing two-tailed tests. That's the topic of this lesson. I'm going to take you through a couple of examples. I'll probably take you through example 6, and I might take you through one of the actual exercises. Your classwork is to finish exercise 7D. All right. So 7D is your goal by the end of this lesson. At the end of this lesson, I want you to submit pictures on Microsoft Teams because no one's done that yet. Remember, that's my evidence that you're out there working. I can see it's 7 people are watching, but I mean, watching is easy. Doing is obviously a much more different and challenging thing. Okay, cool. So if you haven't popped your name in the live chat, do that. The example we're going to be using is 7D, and I'm not going to do the critical regions thing because I don't like it. I just think it's longer. If I have a choice, I won't do critical regions. And also, we've covered critical regions already. I'm just going to do straight up analysis. Brilliant, excellent. So I can see what you guys coming in. So let me read example 60. So long period of time for Enrico's restaurant, the ratio of non-vegetarian to vegetarian meals is 2-to-1. So for Enrico, you can't see that, sorry. I need to check my screen to see what you can see. So Enrico, it's 2-to-1 non-veg versus veg. So most people prefer non-vegetarian. In Manuel's restaurant, 104 now, Manuel's restaurant, thank you for all you guys who did subscribe, I really appreciate that. He does a test. So we've got Manuel, and 1 out of 10 chooses to be vegetarian. Chooses for the vegetarian meal. I want to see, is Manuel's restaurant, different to Enrico's restaurant? And the key word there is different, because when you see the word different, you are implying a two-tailed test. Yeah? Different implies a two-tailed test, if that makes sense. I hope everyone's reasonably happy with that. All right? I mean, looking at that, we know we're doing a two-tailed test. Let's set up our hypotheses. So our null hypothesis for Manuel is that there's nothing different in the world. So it's going to be 1/3. Yeah? Sorry, that should be an equal sign, not the other ones are not. So we're going to assume there's nothing unusual about Manuel's shop. It behaves just like Enrico's shop. The other one is that it doesn't behave like Enrico's shop. We're also told that we're going to be doing a 5% level of significance, so the test level is going to be 2.5% for each way, up or down. All right? We will say that if H0 is true, X is binomially distributed. Thank you. X is binomially distributed with, because there was 10 people, there's 10, and the probability is 1/3. So that's N and that's P. All right. I'm going to stop there. So anyone who needs to copy down anything can do so, and then I'll give you the rest of the question. All right. So what we're looking at example 6, which is two-tailed tests, and we're doing example 6, which is page 107. Okay. And what I've done is laid out the question for you. We have Enrico. Over a long history, it's shown that people prefer vegetarians 1/3 of the time, non-vegetarian food 2/3 of the time. Manuel does a little experiment. He asks 10 people what they want. Yeah? Yeah, I need 100K. That would be nice. I mean, I could live stream off my phone. It would be so much easier. Even 1,000, that would be enough. Manuel has 1 in 10 of his people he asks is vegetarian, and he wants to know, is his restaurant different to Enrico's? And obviously that'd be a useful thing to know as a whatever. Okay? So I'm going to rub this out in just a moment. I'll give you about another 20 seconds if you need to copy anything down. Remember, you can rewatch the video. The other video is already up. So you can watch that to your heart's content. So don't stress if you can't copy out in time. Remember, this is also something that we're working to. My connection has gone unstable, so just wait for a second there. Yeah, so that would be nice. I mean, there are people on 100 million. I think T-Series and PewDiePie are both 100 million now. We're not getting there anytime soon. Okay, cool. So that's the working out the question. Let's push on. So you want to know 2 different things you can do, yeah? We know that it's not going to be the upper bound that you're going to be testing here, realistically. If it's 1 out of 10, it's not going to be that there's more people that like vegetarian food at Manuel's than Enrico's, because in Enrico's 1/3 of people like it, and obviously 1 out of 10 is less than 1/3. So the sum we're testing is the probability of X being less than or equal to 1, and we're testing it at 2.5%. Now, why are we testing at 2.5%? Because it is a two-tailed test, so you split the probabilities in half. This is why I like doing it by just doing the actual calculation rather than setting up critical regions. It is pointless setting up a critical region for the upper bound, because 1 out of 10 is never going to hit your upper bound, is it? Yeah, because you'd expect there to be at least 3 people doing being vegetarian, but there's only 1. So there's only 1. It can only be like that it's changed to be fewer vegetarians, not that this is going to be changing to be more vegetarians if only 1 out of your 10 people are vegetarians. So you do this calculation. If you do this calculation, and it's the same binomial that you're comfortable with, you're going to get 0.104. And you can try this on your calculator by all means. Remember, the binomial distribution that we were talking about was X is binomial of 10 and 1/3. And it's 1/3, not 0.3 recurring. Just be careful about stuff like that. Okay, fine. All well and good. What are we going to do now? Well, the idea is pretty simple. If this is 0.104, that's 10.4%. That's a lot bigger than 2.5%. So we're not rejecting the null hypothesis. To reject the null hypothesis, this probability would have to be less than 2.5%. Remember how I described the rejection of the null hypothesis? You're very, very stubborn about trying to keep the null hypothesis. Yeah? If the thing isn't totally, totally unlikely, you're not going to care about it. I hope that makes sense to people, right? So here, 10.4%, that happens like 1 in 10 of the time. That's not enough to convince you that you should reject null, because by chance that would happen 10% of the time. So therefore, you don't have enough evidence to reject the null hypothesis. You accept the null hypothesis, all right? I'm working on that live stream Kahoot thing, by the way. Okay, I can see that. So there's insufficient evidence to reject H0. And remember, you've got to give a word conclusion. There's no evidence that the proportion of vegetarian meals at Manuel's restaurant is different to NBCO's. All right. So that's one example. I'm also going to do 7B question 1, just to take you through the first one. Okay. It's a very, very simple. It's not got many words in it. So I'll give you about a minute just to have that copied down. And I'm going to take you through exercise 7D question 1. All right. For those guys who just popped in now, your rest of your classwork is to finish the rest of 7D. So I'm going to do 7D1 with you, so you only have 9 questions. Once you have finished your work, can you send me pictures on Microsoft Teams? Okay, I'll open up another tab where you can just submit your work. All right. I'm going to give it another 15 seconds for anyone who's still copying. Remember, you can re-watch these videos, and that's kind of why the videos are handy. You can copy them. So you'll copy them. You can use them. You can see them as many times as you want. I seem to have acquired a message. Just bear with me. Someone's opening the fire at me. Okay. So let's do this. Right. So question 2 is a random variable. No, question 1 rather. Sorry, it is question 1. Do you need to no? I mean, submit what you've got. Don't worry. A single observation X is taken from a binomial distribution X is binomially distributed with, yep. So someone's literally asking the questions on there. So I'm just popping back a response. Right, so what we're saying is X is binomially distributed on 30 and P. That's good. Maybe I should just do everything from my house. I'm so bored. I don't know. I hope you guys are all socially isolating at the moment. I've got bare people sliding in my... No, it's literally students. It's literally students. And it's not DMs either. It's literally Microsoft Teams. So yeah, we're testing H0 versus H1. So P equals 0.5. H1 equals P is not equal to 0.5. Right, so just looking at that, H0, H1. So what are we going to do then? First of all, we know it's a 2.5%. Yeah? Why? Half of 5%, 2.5%. We are testing a value of 10. Okay, we'll try a value of 10. So probability of X is less than 10. So that X binomially distributed has now become X binom on 30 and 0.5. Why is that true? Because we're using the what's it called? The null. I mean, I wonder if Steve is watching. I think Steve's got better things to do than watch my videos. If you are watching and you're stealthily watching, pop a message in and I'm happy to say hello to you. Get shouted out on the live internet. In fact, you've actually scared both of them away. Okay, so X is binomially distributed on 30 and 0.5. Okay, so you run that on your calculator. Okay, and remember that's binomial CD. All right, can you do that for me? Work out the probability of less than or equal to 10. So is that, yes, less than or equal to 10, my apologies, on binomial CD, all right? And it's 30 and 0.5 that are your things, yeah? Yeah, so if you are the secret person, just drop a message in the comments. I know that you're who you are and what you need. Right, so if you quick look at, can I ask you to do this question for me? We're doing question 1. We've set up the question. We've seen that it's, when they did the observation, they got 10 or less. Yeah? X is binomially distributed on 30 and 0.5. And once you've got an answer for me, pop it in the chat box. All right? How do you use calculator? I forgot. Fair enough. So I'm just grabbing my calculator. I don't know if you can see this all that well. A bit of garbage on top of it. Here it goes. On. I mean, can you see that's not the best, is it? Go to menu. No, you can see actually, sort of. It's 7, isn't it? Let me just see that. Yeah, it's 7. Hit that. It's binomial CD, so you need to go down 1. And this time you're looking for variable, not list. So list is generally used for, press the on button is always a good place to start, my dude. Yes, you use it with your hand. I mean, all the comedians coming out today, very funny, very good. Subs in those numbers. And here your X would be 10, your N would be 30, and your probability is 0.5. Turn on the common sense mode. Wow, we are spicy here today. And that gives you 0.049. Tell me if you agree with that. Okay. Why are we using variable? Because list just tells you all of them. You only need 1. Yeah. And list takes longer, and you don't need list. List is best used, and list is really, definitely, really only should be used for trying to work out critical regions and critical whatever values. So there's that. All right. So what were we doing? We were doing what, 7D, weren't we? So yeah, I got 0.494. That is bigger than 2.5%. It is not enough reason to reject the null hypothesis because 4.9% is bigger than 2.5%. All right. So we're not going to reject the null hypothesis here either. All right. So I hope that makes sense to you. So you work out the probability, compare it to 2.5%. We are a less than. The reason why we're a less than is because 10 is less than what you'd expect to happen. Because if you had 30 events and you had 0.5, it'd be 15. So you'd expect around 15. So 10 or less we've gone. If that had been like 20, for example, so there'd been 20, I would have gone this way. 20 or more. Yeah? Is that making sense? It depends on your direction. All right? And your direction is decided about comparing it to which is the sensible test. Really, you should do both, but one of them just won't make sense under certain circumstances. All right? So I hope that does make sense to you. If you've got any further questions, let me know. I'm going to hang around again for 3 or 4 minutes just to get, if anyone wants to ask me any furthers on this, pop up in the live chat if you've got a question, okay? And then I'm going off, okay? I hope that makes sense to everyone. I'm going to be online for the next 4 minutes. I wonder who the 9th person is. We deserve a live group. Well, it's easier said than done, isn't it? I think you can screencast it off Google Classroom. I'll try that at some point. The previous was bare hard. I mean, what was the thing that made it hard? As I said, I'm hanging around so you need an explanation. So ask again. Remember, you couldn't understand to complete it. So we're not rejecting null at all. We'd reject null if it was less than 2.5%, and it's 4.9%. You would not reject null unless your probability. Yeah, I mean, yeah, maybe you might be right. I don't know if you can Kahoot scheme. I'll try it at some point. So can I just talk about things that are important? No, we don't reject the null hypothesis. Why do we not reject the null hypothesis? Because the probability of this happening 10 or less is 4.9%. Yeah, that is bigger than 2.5%, so you do not reject null. Why is that 9th person scared to pop? I don't know. Maybe they're just bored. Okay, and it's fine. We're not going to scare people off. All right. And see, they've gone now. You scared them. Question 3 and onwards from 11G. Which one was 11G? Was that the integration thing? Okay, cool. What in particular? That's the pure 2 one, isn't it? Let's have a quick look. Let's do some of that then. Just grab the book. The thing is with 11G, the maths gets a teensy bit harder, but the idea is the same the whole way through. So first thing you needed to do was, for 3A, split the two things, right? Is Zarif Stalker? Oh, that little kid. Madness. I mean, she was a nice kid. There's worse people to have as a stalker, I think. And she could hardly beat you up, could she? Like 3 feet tall. Anyways, yeah, so just having a look at that question 3 onwards, saying from that exercise, what did you find difficult? Because it's fundamentally the same maths for 3A that it was for 2. In fact, 3A is like 1. So all it was saying was 3A, find A and B, 3B, integrate it, 3, some numbers in. I'm struggling to understand what the issue here is, Kai-san. Just let me know what you can't do, and I'm happy to explain it. But like, for 3, what was the problem? Other than the fact it was split up a bit, which should actually make it easier. Okay, cool. Just as a little gift to the person who's now identified who they are, I'm not gonna score who they are. I'm just gonna explain modulus for 30 seconds, right? So like you guys, you don't need to know about this. I mean, you probably should, but you know. Okay, imagine you had a graph that looks like this, right? Cubic, right? Unknown person that I'm not gonna name online, okay? Because you know they much. So this is your x cubed, right? Fine. What would the modulus of the x mean? It means that these are fundamentally unchanged. This will look like that. Of course it would. Yeah? Why? Because it was positive here and it's still positive there. All of these x coordinates, every input is positive, right? Now back on the other side, what used to be -1 is now a +1. Yeah? Because when you modulus minus, you get a plus. So this thing will behave like as if it's +1. So what you'll see is the graph will look like this. All right. So the thing I said to you was fundamentally true. All of your negative coordinates will behave like positive coordinates. What is the effect of that? Everything on this side is mirrored on that side because 1 will behave like -1, 2 will behave like -2, 3 will behave like -3. Do you get the idea? So both of the two statements that I made, the statement you made and the statement I made, are not incompatible in any way, shape, or form. They are both true, right? I said to you that everything's going to behave like a positive coordinate, and that's true. Yeah. So -4 now behaves like +4. Okay. You said it's a reflection in the y-axis, and I said, yeah, that's true. It's true because that's the result of what you're doing. Yeah. If everything on this side behaves like everything on that side, of course there's going to be a mirror image with the y-axis going straight through the middle. Okay. So let me know if you understand that. Pop a message. VJ say hi, sisters. I don't have any sisters. I do actually have one sister. She's not watching this. She does know our live stream, but she's not watching this. Okay, cool. So that's brilliant. Okay. Right. So going back to what's his face's question. You don't get to understand what to do after. Thank you for the picture you sent me. You need to integrate the damn thing, my dude. All right. So you've got, from what it's got, assuming that you've got your numbers. Yeah, I mean, I can't comment to the thing that I was just sent, but yeah. Put it this way, they can't all be like you. Let's just leave it at that, old friend. So this is where you're at. Integrating that, what's the problem? You just literally, you can't see any of that. Sorry, I do apologize. Tell you what, I'll rub out the graphs because I think the other dude's happy. You're comparing the answers to physics and math tutor. I mean, that's a good thing to do, Kai-san. I mean, did you get the A and B right? Because that's fundamental. So what did you get for your A and B? Look, those are simultaneous equations, right? You're solving the simultaneous equation. Okay, cool. Goodbye, person I'm not going to name online. I can see a pair of simultaneous equations there. Did you solve them? If you do, did you get the right answer? Can you talk to me? Bye, man. Have a nice day. Yeah, I'm done with you. You know, yeah. This is me and Kai-san talking. You get fractions. Really? Let me have a go at that. I'm going to go on from where you started, which is 2x. I know you can't see this. This is my working out for me. So minus a plus b. So you end up with what? If you add, you want to subtract, wouldn't you? When you get 3a equals minus, yeah, I can see you get fractions, wouldn't you? I see that. Because you subtract and you'd get 3a. When you get 3a equals 7 or something like that, where should you submit your work? I'll open something up for you in our, not in the group chat, but in the actual team itself. Is that making sense? Right, okay, so what I'm going to have to do is do the question, aren't I, really? You're doing 2a here, aren't you? Okay, fine, let's get it going. What I'm going to do is I want Kai-san, you to stay here, and we're going to do 2a, all right? We're going to do that together. And then we'll see what goes down. All right? I'm just pulling up the questions. What, 7? No, it was 11, wasn't it? Something like that. Yeah, do you know what? Let's just do one together, because then we'll know. I don't want to leave you, you know, that you don't really understand what's going down. All right? So let's just do this one together. So it says integrate, I think you can see this, of 2, and I agree with you in terms of what your method is. I'm not agreeing with you that you got it right. You might not, I don't know. X plus 1, 2x minus 1. X plus 1, 2x minus 1. Okay, is that making sense? So what we're going to do is we're going to do the algebraic long division first. That's correct. Good shout. So that's going to go 2x squared plus 6x minus 2. Let me see if you agree with that. Yeah, you do. And the expansion of this guy will be 2x squared. Negative, yes, and negative x plus, so we're plus x there, which it is minus 1. I think I found your mistake, because 1 times minus 1 would be minus 1. That I think I found. Okay, so that's one mistake we found straight away. Can I just show you that? Kai-san, you should, everyone, I don't really know about everyone else, but you should still be here. Your mistake is that there should be a minus 1. Bye guys, integration is easy. Well, this one is, you've only just made one tiny mistake and it's killed you, which is the plus 1 and the minus 1 times to give you minus 1, not plus 1. All right. So if you redo that now, that should now work. If it doesn't, we can pick it up in Thursday's live stream. All right. I hope that's okay for you. Do you see where you made a mistake? Can you pop it up in the chat box? People are sending me pictures. We'll see how you're doing exactly. I mean, yeah, I hope we do see only good results. Okay. Positivity. So I'm hanging around here for Kai-san, just to make sure and he understands where he made his mistake. I'm not going till he's done. I'm getting kind of random emails. Okay, brilliant. Okay, you're cool then. So what I want you to do is obviously like have a go at retrying that, okay? Send me another picture, and it comes to it. On Thursday's live stream, we'll concentrate on that, all right? I mean, it's very, very easy to say things are easy if you know how to do it, right? But if you don't know how to do it, well, it's a bit of a sticky one, isn't it? Some of the stupid things people ask me. I mean, the first kid was fine. The modulus one, you know, that's a sensible question. But this, I mean, this is Disney. Not you, by the way, actually. Okay, cool. Right, so I'm clearing off. Nothing further to say on this. We hit 30 minutes as well. So if you need any further help, you can message me, or you can probably, to be fair, the way I'm going to answer it is on Thursday's live chat. Okay? Keep asking questions the way Kai-san did. You see that we went to the end of it. Okay? You take care now. I'll see you around. Bye.